So we have covered at the introduction part of computer organization and architecture. You don't need that part to be covered. You just need have to the basic idea, that is uh, ALU, register, and CU. I have understand what the things they do. Memory, as you know that it saves data. We will deep dive into these structures in the next part of this video. So let's start the video with von Neumann architecture. So after tuning machine, the concept that came into the picture, that is von Neumann architecture. So what von Neumann do? He described the complete architecture of a machine. That is, uh, there should be a memory, there should be a CPU, and there should be the input output. Okay, so there is memory. Memories has two parts saved, that is programs and data. So two parts, both are infused in memory. And there is CPU. CPU has three parts, that is registers. You have studied registers in digital electronics, I suppose. If you don't, in the next part I will discuss multiplexer. So there I gonna discuss about registers too. So hold on. Then there is arithmetic logic unit, that is ALU, and there is control unit, that is CU. And here we got the input and output. So memory has two parts, that is one is program and another one is data. So yep. So I have drawn a structure, that is many parts. You can suppose there is another data, there is another program. So what is program here defines, if we suppose the machine is started, so it is defined by some algorithm or some structures. So it is defined by the program. Okay, the program we have written in the computers, yes, you can consider is at that too. So what is A1 and A2? A1 and A2s are the addresses. Okay, so if we consider it as our memory, in memories there are many parts. One is data and another one is program. There can be two type of data only in the computers, that is one is data, another one is programming logic, or what you can say programming. Okay, so you can say programming workflow or logic. So there's logic, I for instructions, that after that this will happen, after that this will happen. So PI generally stand for programming instructions. So there is data and programming instructions. And even A2 is defined, here we can write A3, A4. So these all are the addresses of this, like data 1, if we consider as data 1, so data 1 address is A1. And programming infrastructure, or what you can say infrastructure, so programming logic is at A2. So this is the address of this memory. So memory is connected by this CPU, and from memory there I can see a unidirectional line. Okay, so this is called unidirectional, and this or this or this is called sorry, this is called bidirectional. And if the arrow is going toward only one direction, we can say it's unidirectional. So there is a bus. So what bus do, I said is previously that bus connect the all components and communicate between them. So from cpu from cpu, in cpu all the data is stored. So all the data is transferred between cpu and the memory. Okay, and the address is given to memory from the CPU, because CPU decide what to do with the data or the program, where to set it up. So CPU do all that thing, or we can say control unit do all that thing, that where the data should be gone. Like if there is D1 data in A1 part, so if the new program come, then it will go to A5, because A5 is not full. So if A5 is full, it will store the data in the next section. So the address part is handled by the CPU. So uh, address bus is unidirectional, and is goes from CPU to memory, and the data is shared between CPU and the memory in both direction. Means from memory data can go to CPU, or from CPU memory data goes to memory. So DB stand for data bus, AB stand for address bus. So address goes to CPU to memory, but data goes from memory to CPU, CPU to memory. Okay, and it is very evident that it should go, because if we have to write some data from the memory, data bus should go from memory to CPU. If the work processing is done in CPU, so from CPU the memory should so the data should go from CPU to memory. Enough of this shit. So next, move on to the next structure, that is from CPU. Input goes from generally to CPU, and from CPU it goes from to the output section. So here we conclude the von Neumann architecture. There is one section of memory. Memory has two parts: programming logic and the data section. There is CPU and there is input output. We give input to CPU and get the output in memory and CPU. What happens is from CPU addresses goes to the memory, that where we should put the another data. So it is evident that from CPU the address bus should connect to the memory, and there is data bus also, that data goes from memory to CPU, CPU to memory. So I hope it is clear. Then there is Harvard architecture. What Harvard architecture do? But oh sorry, I guess I'm looking at here. This bus, I guess. So, what Harvard architecture do? There's a problem that in von Neumann architecture, programming and data both are in a memory. So, what Harvard architecture do? Harvard architecture separate this out. That uh, it made a separate memory for the programming logic and a separate memory from the database. What it do now? As it separates out, it easy to manage. I mean, it's scalable, it's manageable. That's why Harvard architecture came into the picture. So, von Neumann architecture is done. I will meet you with some new topic of computer architecture. So, bye.